0.1. This will be the first assignment. And we're going to talk about tangent line problems. Remember we went back and talked about there were two basic types. We're going to go ahead now and start attacking these tangent line problems. Now that we have limits, we can start to do this. Okay. If you remember, we had talked about that the slope of a tangent line was, if you have a function, looks like this. We want to find the tangent line here, that slope. What we had to do was pick some point up here. So this is our point x, and this is going to be x plus delta x. So this is delta x. And we find that slope. Now what we knew is as we brought this closer and closer, the slope of this secant line becomes closer and closer to our tangent line. And this is f of x, and this is f of x plus delta x. Some of you are going to see this looks awfully familiar. Okay, what the slope of the tangent line basically is, it's the limit as delta x goes to 0, which is just what we were talking about here. I want to shrink this point down of the slope of my secant line. Okay, well the slope of a secant line is easy to find. It's going to be f of x plus delta x, this top one minus this bottom one, f of x, there's your y2 minus y1, over x plus delta x, this one minus this one. Okay? Now you can tell these cancel out. So the slope of the secant line is basically going to be f of x plus delta x plus f of x over delta x. And this should look awfully familiar because this is basically what you've been doing up until this point. So now all we need to do to find the tangent line is find the limit as delta x goes to 0. So we do limit as delta x goes to 0 of f of x plus delta x. There should be a minus. Minus f of x. Okay, so what you do if you're given some stuff is you just plug these in. Now, and this gives you the slope of the tangent line at point x. All right? Now, this also happens to be the derivative. Which is the first part of real calculus. Yahoo! Finally into some calculus. So the slope of the tangent line is the derivative, and the limit definition of it is this guy up here. All right, now when you look at it, this looks like we're getting slope at one point. All right, and that's what you tell everyone who doesn't take calculus. All right, if they're not in calculus, you tell them you just learned how to find slope at one point. In reality, we're really not. We're still using 2 points. So everything that you learned in Algebra 1 and Algebra 2 and college algebra is still true. You need to have 2 points. But they're very, very, very close. Matter of fact, they're so close, it's hard to tell that they're really 2 points. And this is really what a derivative is. We're still finding the slope of a tangent line. We are still using 2 points. But the second point is extremely close to the first one. All right, so let's talk a little bit about how you write derivatives. And you're going to get a variety of ways of doing them, and you're going to have to be able to do all of them. You'll see them written as dy dx or ddx of f of x, and this is Leibniz notation. This is really the preferred notation for most people. It's this one right here. Now you read this right here. It's not dy over dx. And the d, by the way, means derivative. This d you can read as the limit as delta x goes to 0. Delta x. That's what dx means. Okay. This reads as the derivative of y with respect to x. This is not really division. This is just the way it's written. And this guy right here you would read as the derivative of f of x with respect to x. Now there's other ways to write this too. You're going to see people do y prime or f prime of x. This is Newtonian from Sir Isaac notation. It's very commonly used. However, you may not necessarily know what you take the derivative with respect to. Another way, very infrequently you see it written, is d sub x of y. All right, primarily you're going to see them written in these 2 ways, and you need to be able to go in and be able to translate between these 2 guys.